Okay, so open up to page 8. Okay, all we're going to do for these is describe the transformation, state the domain and range. Okay, our calculator is going to be our trusty little friend here to help us visualize the domain or see the domain and range, so we don't have to super stress about it going on this, even though we could probably sketch a picture of the graph out beside it and be just fine. Okay, but transformations, for this one we have a flip over the y. Okay, plus 4, so we moved left 4, and we moved down 1. Okay, so let's pull out our calculator and let's graph this equation. Y equals negative square root of x plus 4 under the radical, and then a minus 1 outside of the radical. Hit the graph button. And it did not flip it for some reason. I don't know why it's not flipping it upside down. I guess there's something, my calculator's got something happening here. Hit a big old, nope, doesn't like that either. Okay, regardless, it would look something like this. Let's go out to the side and just sketch a picture of it. Okay, he went left 4, down 1, and he is flipped over the x. I don't know why I put y. Flipped over the x, so he looks something like this. Okay, so our domain, how far left did we go? We actually moved left 4 units. Positive infinity. And for the range, negative infinity all the way up to negative 1. Okay, I'm actually going to completely rewrite number 12. Sorry, I'm going left to right instead of down the columns. Okay, I'm going to rewrite number 12 so that it looks a little familiar. Okay, so we have the square root of negative x, and then we have a plus 4 on the outside. Okay, just kind of moved everybody around a little bit. So we are flipping over the y. And we are going up 4. Let's see if our calculator will do this one for us. If not to give up on the calculator and just sketch pictures on the side. Okay, so we have the square root, negative x, and then plus 4. And this one did it just fine. Okay, so again, here's what the picture looks like. Went up 4, and he flipped over the x, so he went this way. Okay, so my domain, farthest left I will go is negative infinity, and I will go all the way to x of 0. The lowest I will get on the range is positive 4, and the highest is infinity. Okay, again, number 9, that fraction of 1/2, that's up in the exponent, is taking the place of the radical over this x minus 3. Okay, so if you just want to go ahead and draw it in there so you don't mistake that. Okay, and this one is going to the right 3 and up 2. Out to the side, we'll sketch a picture, right 3, up 2. It's a square root function, so he looks like that. Okay, my domain, since I moved to the right 3, my domain is now 3 to infinity. And I went up 2 on my range, so the lowest I will ever get is that positive 2, and the highest is infinity. Okay, again, let's rewrite this one. Okay, so we have the square root of negative x plus 4 under the radical, and then a plus 5 on the outside. Okay, exact same equation, just rewritten a little bit differently. Okay, so I went left 4 units, up 5, and then that negative that's inside flipped us over the y. Okay, so left 4, up 5, and instead of pointing to the right, we are now pointing to the left. So it looks something like that, which gives me a domain of as far left as I could possibly ever want to go, all the way to negative 4. With a range of 5 to as high as I could possibly ever want to go. Okay, I know number 10 looks a little different too, but nothing a quick little move the 2 to the end can't fix. Okay, so we have a flip over our x-axis, so we flip them upside down. Left 1 unit and up 2. Okay, so left 1, up 2, and he is flipped upside down. So my domain, the farthest left is negative 1. I go on to infinity. For my range, the lowest I will ever get is negative infinity, and the highest I will get is positive 2. $14. We are going to flip over the y. So again, he's going to be pointing to the left instead of pointing to the right. We are going left 3 units, and we are going up 2 units. So if we sketch a picture, left 3, up 2, and we're pointing left. That gives us a domain this time of going as far to the left as we possibly want, all the way to negative 3. In a range that never gets lower than positive 2 and goes on to infinity. Okay, 11. Negative x means we flip over the y. Again, pointing to the left, and we're going up 3. Okay, up 3, and we're facing this way instead. Okay, which literally just flip-flops our domain. Okay, so we go as far left as we possibly want to go, up to 0. And our range takes us to from 3 to however high we want to go. Okay, the lowest we'll ever reach is positive 3 on the Y, and forever as far as how high. And 15. Another flip over the Y. Left 3 and down 5. Okay, again, out to the side, sketch yourself a picture. So we went left 3, down 5, and we are pointing to the left. So our domain is from negative infinity to negative 3, and the range is from negative 5 to positive infinity. Okay, unfortunately, domain and range, y'all, if you are struggling with it, it's not going away. Okay, you will do domain and range until you graduate college or you finish your last math class in college. Okay, you are always going to have to understand domain and range. Okay, flip it over. Page 9. Okay, we're going to graph it, and again, state the domain and range. Okay, I'm only going to do 1 through, I'm going to go ahead and do all of them with y'all. Why not? Okay, this one, I'm just going to do them quickly. Down 2, and that's all that's happening to it. Domain is 0 to infinity, and the range is negative 2 to infinity. Okay, plus 2 actually moves us right 2, and that is all that's happening on that one. So only our domain was changed. Instead of 0 to infinity, we're now 2 to infinity. And our range is staying a normal square root range of 0 to infinity. Okay, number 3, it's left 1 and just stretched out, so he just gets taller faster. Okay, no, that does not affect the range at all. Okay, just because he's getting taller faster doesn't change anything. Our domain did change though, so we're negative 1 to infinity. And the range, like I said, did not change at all. Number 4, left 2, down 2. Domain negative 2 to infinity, and the range negative 2 to infinity as well. Number 6, right 1, up 1. So the domain changed, moved 1 in the positive, so 1 to infinity. And our range also moved up 1. Okay, last one for square roots. Okay, we are moving to the right 3. And then we are flipping ourselves upside down. Okay, domain is now from 3 to infinity. And our range, because we do lowest to highest, so bottom to top, the lowest we will ever get is negative infinity, and the highest we will ever get is 0. Okay, remember, domain and range of cubed root function is easy. No matter what I do to it, no matter where I shift it to, the domain and range of a cubed root is always negative to positive infinity. Okay, so the only thing that's going to change here is the way that the graph looks. Okay, in this case, instead of turning at 0, 0, we are going to turn at positive 1. Rough sketch looks something like that. And like I said, the domain and range never change. Okay, so technically you could go through here and do this on every single one of your cubed root functions. Because it does not matter how many transformations I make to this, still never going to change. Okay, number 8 is going to the right 4. Okay, number 9, the only thing, he's still staying at 0, 0. He just gets taller, faster, stretched out. Okay, number 10. Again, you could go through here and mark all these domain and ranges. I'm about to do it real simple and account for both of them in one set. Okay. Number 10 went to the left 2 units. Starting low, ending high. Important to remember about the cubed root, especially when this guy is next. Okay, this one moves down 1 and he is flipped, so he starts high and he ends low. Okay, and for the final cubed root function, left 2, down 2. No flipping, so, whoops. Starting low, ending high. Okay, the next one is a perfect example of how y'all will see a word problem and you probably are just going to leave it blank on the test when really it's a super easy question. Okay, it says the speed of sound in feet per second through any air temperature is measured in degrees Celsius, where T is the temperature and V is obviously the speed. Okay, so we only have 2 variables here. We have the feet per second and T is our temperature. Okay, identify the domain and range. Okay, if T is replacing our X, okay, our temperature could technically be anything, correct? Okay, you can have negative temperature. So you could have a temperature of negative infinity to positive infinity. Okay, for the range, we are looking for speed. One thing you cannot have is a negative speed. Okay, so our range is going to be anywhere from 0 to infinity. Okay, you can't have a speed of negative. You can move in a negative direction, but we would never have a speed of a negative number. Okay, and the last one asks us what is the temperature of the air if the speed of sound is 1,250 feet per second. Okay, so we're going to have to do a little backwards working here. So we have 1250 equals 1087 square root of, here's our missing, that's what we're looking for. Okay, so we have some algebra to do. Okay, in order to do this algebra, to get rid of this as our denominator, we are going to multiply both sides by it, okay, which cancels out on this side. Okay, so that's 16.52 times, what did that say, 1250. And that gives us 20,650. And that equals what we have left over here. Okay, the next thing, we have multiplication. To undo multiplying, we divide. So I'm going to divide both sides by this 1087. Eliminates it there. Divided by 1087. Okay, 18.997. I'm going to round that to 19. Okay, two more steps. To undo a square root, we square both sides. Okay, that makes my radical go away. 19 squared is 361. Okay, and the only thing left to do to get the temperature by itself is to subtract 273. When I subtract 273 from both sides, I am left with T, which is the variable that I'm looking for. And it gives me a temperature of 88 degrees. Okay, so before you get all excited that you got the answer, ask yourself if that makes sense. Okay, does a temperature of 88 degrees make sense? And yes, it does. Okay, you could obviously have a temperature of 88. Okay, and then ask yourself what that means. So that means that if the speed of sound is 1,250 feet per second, the temperature of the air that it traveled through was 88 degrees.